Side AB and AC and median AD of a triangle ABC are respectively proportional to PQ, PR, and AM of the triangle PQR. Show that triangle ABC is similar to PQR. So first thing first, the diagram is there. Guys, in this thing, okay, let me explain proportion and median. So what is a median? Median is nothing but it's a line from a vertex to opposite side which divides the opposite side into two equal halves. So AD is equal to DC. PM is another median which is thus dividing QM and MR. I mean, it's dividing QR into two equal parts. So QM is equal to MR. Simple and straight. And then what else is given? So we have given AB by PQ is equal to AC by PR, which is equal to AD by PM. This is the equation 1. Right? Let's write the other part also. Other part being as AD is a median, BC by 2 is equal to BD, which is equal to DC. Right? And next is as PM is a median, QR by 2 is equal to QM, which is equal to MR. Right? All this helps writing now. So here, for this particular question, you need to approach this way. Extend this and extend this as well to such an extent that you have to make AD being equal to DE. So you have to do in such a way that this particular length is equal to this particular length. And we have 1/2 somewhere over here. So PM is equal to MN. Okay, so let me show that this length is equal to this length, that is PM is equal to MN, and AD is equal to DE. Okay, so that's the construction we have to do, and then just join them. Right, now we are looking at a, okay, that is somewhat better, not exactly, but what I'm trying to do is draw a parallelogram. So okay, you can imagine it to be a parallelogram. It doesn't look like though. How come? Okay, this is not proper, that's why. Anyways, so see, this makes it a parallelogram. How? The diagonals of a quadrilateral are bisected, so it has to be a parallelogram. Okay, that is a property that again you need to go to basics and have a look. So these are properties, it's just memory oriented. So physically you can actually draw a parallelogram and draw diagonals and measure them. So all these are what is it called? Lemmas, right? So next is construction. We constructed, right, quite a few things. Extend AD to E such that AD is equal to DE. Okay, then join BE comma EC. Next is extend PM to N such that PM is equal to MN, and then next step is join QN and NR. Okay, so this is the diagram. So my suggestion is now you pause and draw this diagram because the answer is a bit lengthy and going back and forth to the diagram does not, it won't be helpful. So what you do is you pause the video, draw this, and then start the video again. Okay. So what I have done is I have drawn it on a piece of paper and I have it in front of me. So I'll be referring to that and teaching you guys. So you guys can refer your own diagram. So now the next step is to tell that in quadrilateral ABC as diagonals bisect each other, we have ABEC is a parallelogram. Then similarly in quad PQNR as diagonal bisect each other. PQNR is a parallelogram. Okay. So what does it make? It will help us to conclude that actually I needed some space. AC is equal to BE. This is equation. Oh yeah, we need to call the equations, right? This is 1, this is 2, this is 3. Again, I don't know where it will be used. I'm just calling them. This is equation 4. And here, again, look at your diagram. It will tell PR is equal to QN. This is equation 5. Reason being, opposite sides of parallelogram are equal. So as opposite sides are equal, right? So you need not write the reason again. It's by default understood. Okay. So my writing is a bit not neat over here, but hopefully you guys understood. So next we have, so now what we have to do is we need to consider triangle ABE and triangle PQN. Again, please see to that you have drawn the diagram. If not, you won't understand. By 1, we have the ratio AB by PQ, AD by PM, and AC by PR. Okay, so what you can do here is multiply AD and PM, multiply and divide actually. Multiply and divide with 2. Okay, so I mean it doesn't make sense. Multiply and divide with multiply and divide AD by PM with 2. And one more thing we need to do, manipulate this over here, is by equating AC to BE and PR to QN. That is replacing that and substituting from 4 and 5. Equation 4 and equation 5. So what do you get? See, what I'm trying to do here is, so I actually didn't tell you the agenda, sorry. I went with the flow because this particular question has a flow. We have to prove that ABC is similar to PQR. So we already have AB by AD, AB by PQ is equal to AC by PR. So all I have to do is either prove BC by QR is equal to all of these ratios, or if not, I just have to prove the included angle, that is this, is equal to this. If I prove that those two angles are equal, I'm done. So how am I doing that is, I'm trying to prove that angle BAE is equal to QPN. Okay, I'm trying to prove this angle is equal to this angle. So if I prove that those two angles are equal, then double of that will be, well, this entire thing, and double of this will be this entire thing. Reason being, in a parallelogram, the angle gets bisected. So double of this particular angle will be this entire angle. So similarly, double of this angle is this entire angle. So if I double it and B, so we have BAC equal to Q piece R, right? Then we have triangle ABC is similar to PQR because the ratios are already there. By SAS, we can prove it. So that's what I'm trying to do. The whole process is to just to prove that this angle is equal to this angle. So we're almost there, just a matter of few more steps. So by converting, making a bit of manipulation to this. So we have AD times 2 divided by PM times 2, which is equal to AC is BE and PR is QN. So we have AB by PQ is equal to AD is 2 times AD is AE and PN is PM is PN. 2 times of PM is PN. Why? Go back to your diagram. I'll show you once. Double of AD will be AB. Simple reason being AD and DE are equal. So double of AD is AE. Double of PM is PN. Right? So that's how it is. And now we have all of them being equal. So the ratios are equal. So what can you prove? These two triangles are similar. Therefore, by SSS similarity criteria, triangle ABE is similar to triangle PQN. Right? So we have those two to be equal. Then what else can you tell? Because those two are equal, angle PAE is equal to angle QPN by corresponding parts of similar triangle. Okay, so yes, we have the angles to be equal. Now what I will do is I'll multiply this, multiplying with 2. What will happen? So double of BAE and double of QPN will give me, look at the diagram, angle BAC will be equal to angle QPN. Reason, we'll call this as some equation. We'll write the reason first. As diagonals bisect the angles in a parallelogram. And so we have this. We'll call this as equation 6. So from equation 6 and the 1, what 1? This is the one, the ratios. So we can tell at last we have the answer. It's done, guys. So from equation 1 and 6, if I'm right, is 6, yes. By SAS similarity criteria, triangle PAC is similar to triangle QPR. Hence proved. Okay. Big fat answer. All we did was prove that these two angles are equal by doing a bit of error pairing. But it worked out, is it not? I constructed in such a way that this is a parallelogram. So once it's a parallelogram, so we have the opposite sides to be equal. So once this is equal, so we saw that the ratios are already equal. It was not a big deal to prove that this particular triangle is similar to this particular triangle. Since those two are similar, the angles are equal and the double of the angle will also be equal, and thus we have the answer. So now you can pause and have a look.